With trigonometry, there are three particular ratios that we use. They are on your calculator, and they're called sine, and we just write sin for short, cosine, which we just write cos, and tangent, which we write tan. We'll look at the calculator a bit later. So trigonometric ratios are the particular ratios of the sides of our right angle triangles. Now, for sine, we say it's opposite over hypotenuse, and we can write it in fraction form, and we use the letter S to stand for sine, O to stand for opposite, and H to stand for hypotenuse. For cos is the adjacent side over the hypotenuse side, so we can write it in our fraction form like this: cos, the C, A, adjacent, H, hypotenuse. The last one is our tan, and that is the opposite side over the adjacent side, and written in fraction form like that, and then T for tan, O for opposite, and A for adjacent. You can use this same SOHCAHTOA to help you remember the order of which side goes over which for each of the trig ratios. So sine, opposite over hypotenuse, cos, adjacent over hypotenuse, tan, opposite over adjacent. SOHCAHTOA. Can you pause the clip now and write that down? The whole screen. So our as we did in the last lesson, opposite is opposite the angle that's mentioned, adjacent is next to the angle, and the hypotenuse is the longest side, as we did in the last lesson. So our sine just tells us to get whatever is written on the opposite side and put it over the hypotenuse side. Our cos is our adjacent side over hypotenuse, and our tan is our opposite over adjacent. You can see we've just used the first letter for each of the words, hypotenuse, adjacent, and opposite, so we don't have to write the whole words out. So if I'm looking at this particular triangle, the reference is angle B. So our hypotenuse of the right angle triangle is BC, but our adjacent side is in reference to this angle, so that would be the side AB, and the opposite side would be opposite that angle, AC. So if we have to write out our sine, we take our opposite side, which is our AC, and we put it over our hypotenuse side, which is BC. For cos, we get the adjacent side, AB, and write it over BC. For tan, the opposite, AC, over AB. Can you pause the clip and just write this slide out as well, please? Another example is when the sides are written in this single letter form, so the lowercase. Our hypotenuse here is just called X. Our adjacent side, because this is the angle marked, is now our Z, and our opposite side, opposite the angle marked, is our Y. So sine, opposite over hypotenuse, now becomes the Y over the X. The cos is the adjacent side, the Z, over the X hypotenuse side. Tan becomes opposite over adjacent, so Y over Z. Another example is also where most of them will end up being like, would be when you've got actual measurements. So here the hypotenuse, the longest side is 41. The adjacent side, the one next to the marked angle, is our 40. The opposite side, opposite our marked angle, is 9. Okay, so for sine, it now becomes 9 over 40, opposite over the hypotenuse. You can put these in decimal form, but fraction form's fine. Cos, the adjacent side, and you divide it by the hypotenuse. And tan, the opposite side, divided by the adjacent side. Sometimes you get asked to draw diagrams from written information. So an example of this would be to sketch a right angled triangle with these are your vertices. The side RQ has to be opposite the angle RPQ and adjacent to this particular angle. Name the hypotenuse. Okay, if we draw that triangle, have a look here. I've got a right angled triangle PRQ. The side RQ, so if you have a look at that, RQ is opposite the angle R to P to Q. It's opposite that angle. The adjacent one is adjacent to, side is adjacent to the angle QRP. QRP is adjacent. So the RQ is also, it's adjacent to this angle, but it's opposite to this angle. So that has to be the order that it goes around. So that's why the hypotenuse is PR. So that's just wording practice. In this diagram, you're told the actual trig ratios, but you are asked to work out which angle it is talking about. So here, if you look up IJ, this side here, over HJ, which is the hypotenuse. So for sine to be opposite over hypotenuse, I need the angle where IJ is opposite. So that would be this symbol here, which we call alpha. So alpha would go there. Sine of HI over the hypotenuse. So HI has to be opposite the angle, and it's opposite this angle here, and this symbol is called beta. Cos of IJ over HJ, so again that's our hypotenuse. So IJ needs to be adjacent to the angle for the cos ratio of adjacent over hypotenuse. So IJ needs to be adjacent to the angle, and it's adjacent or next to the beta. Over here, cos of some angle is so adjacent over hypotenuse. So again, I need the HI side to be adjacent to the angle that it's talking about. So that side is adjacent to this angle, so it's alpha. Now tan is opposite over adjacent. So I need IJ to be the opposite and IH to be adjacent. So opposite over adjacent. So that will be for alpha. And then when it's flipped around the other way, opposite over adjacent, that will be this one. So it's beta. Okay.